let's look at question 4 of this year 2026 NECO pass question. As we have it here, that figure 4.4 shows the elevation of a truncated cylinder at both ends. Question Roman figure 1 says that draw full size the given view, and Roman figure 2 produce the pattern development or surface development. Okay, so let's see what we have here as dimensions on the figure. So we have the diameter of the circular end is 40 millimeters, and then we have the height to be 80. Distance from here to here is 80. From here to here will also be 80, and then we have the cutting plane inclined at 30 degrees to the horizontal both up and down. So we have that. Okay, so let's see how this construction can be done. And then the seam, that is where we are opening from, is this line CC. So let's see how this can be done. So what we are going to do first is to draw a horizontal center line. So here I have horizontal center line here like this. Okay, then I'm going to draw a vertical center line, So here I have a vertical center line. Okay, so I have this. All right, so we have this now. Then we are going to divide the diameter of the circular end by 2. That is 40 by 2. It gives us 20. So take a measurement of 20 millimeters on the ruler with the compass. So put the pin at the point of intersection of the two center lines and turn it round to have a circle. So turn it round to have a circle like this. Here we have a circle. So this circle now, we are going to divide it into 12 equal parts. Okay, so with the set square, so I'm drawing a line, so this way, and then slide it to this side. Okay, so all right, so draw a line, and then so you turn it this way. Okay, so draw this line, and so bring it here. So draw this line. All right, so we have the circle divided into 12 equal parts. So I'm going to number this as 0. So this is 1, this is 2, here is 3. Okay, so then here we have this to be 4. So this is 5, this is 6, 7, and this is 8. And then here we have this to be 9. This is 10, and here is 11. So here we have 11. Okay, so we have divided the circle into 12 equal parts. So the next thing to do is that we come up a bit, okay, and then we draw a horizontal line like this. Then we are going to draw a line, so from 0 as a vertical line. So we draw a vertical line from 0, so it goes up like this. Okay, so let it go up. So come to this point 11. It is for both 11 and 1. So draw a vertical line like this, and then come to 10. So for both 2 and 10. Okay, so draw a vertical line, so like this. Okay, so we have this. Then come to 8. So for both 4 and 8. So draw a vertical line like this, and then come to this point 7 for both. So draw a vertical line and then come to this end. Okay, so draw a vertical line this way. So we have this. Okay, so we the next thing to do is that we want to produce the the front elevation as we have produced the plan. So we take the 30 degree set square. So 30 degree set square. So setting it at this point. If you look at what we have here, so the cutting plane starts from this point and it goes up like this. Okay, so that's what we are doing. So with 30 degree set square, so we are going to bring it. So bring it to this point. Okay, and then we draw the cutting plane, the one at the bottom like this. So we have this. Okay, so that's the cutting plane there. So we now take 80 millimeters. So from here we take 80 millimeters up. So this is 80 millimeters. So we have this. Okay, so at this point here, I'm going to take a measurement of 80 millimeters again at this point. So I need to extend this line. So I will extend this line here. Okay, so I'll come to this point from here, take a measurement of 80. So I'll just connect this together. So okay, I didn't do it exactly on the line on the extreme. So I just, okay, so that's it. So I'm connecting these 2 points together like this. So this is the cutting plane up here. Okay, so you can see what we have just as it is given to us in the drawing. So so we make this line, so make this a thick line from here to here, and then make this also a thick line from here to here. All right, so we have this. Now to now do the enlargement, sorry, the surface development of the cylinder. Okay, so what we are to do is that, so we are going to project line, horizontal line from this point. So you draw it to this side like this, and then so you come to this point here, I mean this point. Okay, that is for the first one that we did is for 6, while this one is for 5 and 7. So draw horizontal line to this side. Next is for 4, 8. So draw horizontal line like this. Next is for 3, 9. So you draw horizontal line in this direction. So next we have for 2, 10. So draw horizontal line. So next we have for 1, 11. So you draw horizontal line here like this. And then for 0, so draw horizontal line to this side. Okay, so when we come up here, okay, so when we come up here, okay, so we draw for 6, so it goes in this direction. Okay, so next for 5, 7, so draw horizontal line this way. And okay, so for 4, 8, so at this point, so draw horizontal line in this direction. So for 3, 9, so you draw horizontal line like this. And for 2, 10, so draw horizontal line this way. And for 1, 11, so draw horizontal line in this direction. And for 0, so you draw horizontal line in this direction. So we have this now. All right, so having done this, the next thing that we are going to do is that we move away a little bit from the given view, and we draw this vertical line like this. Okay, so this is going to be, so we are opening from 0, so this is 0, and then this is 0 up here. So let's take note of that. So we have this. Okay, let's take notes. Okay, so we have this now. All right, so don't forget that this is the seam. So we have CC here. We are cutting it from 0. Okay, all right, so then the next thing that we are going to do is to calculate the circumference of the circular base of this cylinder. So diameter is 40. Okay, and then the circumference is pi d, that is 3.142 times 40. So 3.142 times 40, that gives us 125.68. So I'll make it 120, I'll make it 126. So 126. So 126. Okay, so just let me take this. So use this one. So this is 100. So I have 26 left. So I will add 26 to it. So this is 26 millimeters. Okay. So at this point, so I'm going to draw a line because we need to divide this distance. So this is 0, 0. So this point also 0 here. So we need to divide this distance into 12 equal parts. So that is 0, 0 into 12 equal parts. So I'm going to draw a line. So like this. Okay. So and I'll take 12 equal points on this line. Okay. So this is 1, 2. I'm using 10 millimeters. Okay. So this is 3. So here is 4. This is 5. This is 6. Okay, so here we have this to be 6. So here is 7. This is 8. This is 9. And this is 10. So I'm adding 2 to it. So this is 11 and 12. So we have this. So we join the last one with the end with 0.0. Okay, so then taking the set square, setting it along this line and support it with the ruler. So we shift to the next point. Okay, so we draw this line. Okay, so we move to the next point. We draw this. So move to the next point. We draw this. So this is how to divide the line into a number of equal parts. So move to the next point. We draw this. Move to the next point. We draw this. So move to the next point and we draw. Okay. Then so let me adjust. Okay. So we move to the next point. So we draw this to the next point. So we draw, and to the next point we draw, and to the next point we draw this, and last one is this. So we draw this. Okay, so we have this. So as we are opening, so we are opening it from 0. So this is 0. So our next one is what? Is 1. Okay, so 1, 11. So we have this, and then we have what? We have 2, 10. Okay, then we have 3, 9. Okay, then we have what? We have 4, 8. Okay, then we have 5, 7. Then we have 6 as the last one. So then what we are going to do here, we are erecting a vertical line on each of these points. So coming to this point 0 here, so draw a vertical line. So draw a vertical line here, and at this point we also draw a vertical line up. At this point we draw a vertical line. At this point here, so we draw a vertical line. Here we also draw a vertical line. Here we draw a vertical line, and coming here, so we draw a vertical line. Also at this point, so we draw a vertical line. Here we draw a vertical line. Here we draw a vertical line. Here we draw a vertical line here. And then, so here we also draw a vertical line. This line is not straight. Okay. And let me check this line. Okay, it is this line that is not straight. All right, so okay, so we have this now. Okay, so here we have this. So this is 0. So we have 0 here. So this is 1. This is 2. Okay, so this is 3. Here we have this to be 4. This is 5. This is 6. And then, so we have this to be 7. So here is 8. This is 9. This is 10, 11, and then 0. So since we are opening from 0, so line 0 to this is 0 horizontal, 0 vertical, they intersect at this point. Okay, then 1. Okay, so we also have 0 at this point. Let's be doing it together. So then 1 horizontal, 1 vertical, they intersect here, and then so that goes with 11. So we have this point. Okay, so I believe you can see what I'm doing. So 2 horizontal, 2 vertical, they intersect here. So 2 also goes with 10. So we have this point here. Then 3 horizontal, 3 vertical, they intersect here. Okay, then it goes with 9. So we have this point. Okay, then 4 vertical, 4 horizontal, they intersect at this point. Okay, so then that goes with 8. Then we also have 5 vertical, 5 horizontal, they intersect at this point. So just follow this line like this, and that goes with 7. Then we have what we have 6. Okay, then coming up here, so we have what we have 0 vertical, 0 horizontal, so they intersect at this point. So we also have it here. Okay, then 1 vertical, 1 horizontal, they intersect at this point, and then that goes with 11. So this is 11 here. Then 2 vertical, 2 horizontal, they intersect at this point. Okay, so that goes with 10. So we have this. Then 3 vertical, 3 horizontal, they intersect here. That goes with 9. Okay, then we also have 4 vertical, 4 horizontal, they intersect here. That goes with 8. So we have this point. 5 vertical, 5 horizontal, they intersect here, and that goes with 7. Then here we have what we have 6 here. Okay, so we are connecting this point together with the use of a French curve to obtain the surface of pattern development of this truncated cylinder. So we connect this together. So I believe you know how to use the French curve. Okay, so if you don't know how to use it, just look at me here. All right, so I'll connect this together like this. So we need to adjust it so that the shape can come out. And coming here. All right, so we have connected this. Coming up here, so we also have the same kind of shape up here. All right, so and then so on this side, connect this together, and then so connect this together. All right, so and then so the last thing that we have to do here is to make this line a thick line from here down like this, and then so come to this side, we also make this line a thick line, so from here to here. All right, so here we have the surface development of the cylinder. As you can see, it is as simple as I've done it here. Thank you.